Hey, AP Physics students, here are some hints for textbook assignment T 10.1, page 449, number 17. This is about a mass spectrometer. And so when you use a velocity for a proton, electron, whatever you might have, its velocity is placed through an opening into the mass spectrometer. When it gets in this region here, it's encountering a magnetic field. And so, of course, it will change direction. Now, when you look at this problem, the problem doesn't say which direction the magnetic field is. That's because there is a section 21.4, about the mass spectrometer. So the authors are assuming you would look back here and see, for a mass spectrometer, the magnetic field would be, in this case, out of the paper. So if you look at this, you can see exactly the kind of diagram that will help you very much to know what's going on. As these positive charges go in, the magnetic field is going to be out of the paper. And so one of the first things to figure out is, why do the charges go this direction? Why do they travel this direction? And so I'll help you with the right-hand rule. So you're going to start this out thinking through the right-hand rule. Now, the right-hand rule is for positive charges, and these are singly ionized, which means they are the equivalent of one single, so they are the equivalent of a positive, they are equivalent of an electron in charge, and so that should help you figure out which direction. To use the right-hand rule, this is the velocity direction right here. I'm going to point my fingers in the direction of the velocity. Then I need to curl my fingers outward, and my thumb points in the direction to the right. That's the reason that it produces, like that picture you saw, that it produces a semicircle, then it produces a larger semicircle, and that's the way we can separate these masses out. And that's really what this is all about. We want to look at the linear separation. So we're trying to find out this distance here. Well, let's call that delta D. So if D is the diameter of this, and D here is a bigger diameter, we're looking at the difference between these diameters. So the only hint that I'll leave you with to finish is that, of course, we're using the radius formula, which is the mass times the velocity, and that's divided by Q times V. And so you'll do this twice, and you are going to do one of these for carbon 12, one for carbon 13. So they even tell you the masses of these, and the rest of it should be basically just looking for the delta D, which is what we're trying to solve for. I hope this helps. Thanks.